Hello everyone, I am Ujas Sonar from Computer Department. Welcome to our basic electrical engineering presentation. These are my fellow group members. Smart Shinde, Harshal Shirode, Jay Sinha, myself Ujas Sonar, Janvi Sonar, Kaushal Sonje and Altaf Tadvi. We are going to cover the following topics in our presentation. Number 1, introduction to resistant temperature coefficient. Number 2, measuring resistant temperature coefficient. Number 3, types of resistant temperature coefficient. Number 4, uses of resistant temperature coefficient. Number 5, effect of temperature on resistant temperature coefficient. Advantages of resistant temperature coefficient. I hand over the detailed explanation of the above mentioned topics to my fellow group members.
Hello everyone, myself Janvi Sonar. I am telling about introduction of resistance temperature coefficient. Resistance temperature coefficient is a measure of change in resistance of a material with temperature. It is a measure of how a material responds to changes in temperature and is typically expressed in units of ohms per Kelvin. R.T.C is an important property in electronics and electrical engineering as it affects the performance of components and devices. R.T.C is often used to determine the temperature dependence of a material. It can also be used to predict the behavior of a material under different temperature conditions, such as in an environment with changing temperatures. R.T.C can also be used to determine the stability of a material over time.
Hi, my name is Jay Sindha and I am going to explain how to measure the resistance temperature coefficient. The resistance temperature coefficient is typically measured using a device called a resistance temperature detector. This device measures the resistance of a material at different temperatures. The resistance is then compared to the original resistance at a reference temperature. The difference between the two is the resistance temperature coefficient. The resistant temperature detectors are used in a wide variety of applications, from medical equipment to aerospace and automotive components. They are also used in industrial and process control systems, where the measurement of RTC is important for the operation of the system.
Hi, my name is Altaf Tadvi. I am going to explain types of resistance temperature coefficient. There are two types of RTC, positive and negative. Positive RTC means that resistance increase with temperature, while negative RTC means that the resistance decrease with temperature. The type of RTC depends on the material being measured. The magnitude of RTC also depend on the material. Some material have a very low RTC, while other can have a very high RTC. The magnitude of RTC is important when selecting material of electronic component, as it affects the performance of the device.
Hello everyone, myself Harshal Devendra Shirudi. Today I am going to explain you the uses of resistance temperature coefficient. Let's start. What are the uses? RTC is used in a variety of applications from medical equipment to industrial and process control systems. It is also used in the design of electronic components such as transistors, diodes, and resistors. RTC is also used in the design of temperature sensitive devices such as thermistors and thermocouples. RTC is also used to predict the behavior of materials in different temperature conditions. This can be useful in predicting how a material will react to change in temperatures, such as in a cooling system or in an environment with changing temperature.
Hello, my name is Smart Shinde and I am going to explain about the effect of temperature on resistance temperature coefficient, that is RTC. The value of the temperature coefficient of resistivity in semiconductor and insulator is negative. The temperature dependence of resistance in conductors, semiconductors and insulator are represented in figure 1 as well as figure 2. Here you can see, by observing the figure 1, the curve in figure 1 shows that the value of resistance increases with increase in the temperature. The value of resistance at 0 unit of temperature is represented as R0. The curve in figure 2 represents the typical nature of the resistance of a semiconductor as a function of temperature.
Hi, my name is Kaushal Sonje. I am going to explain the advantages of resistance temperature coefficient. RTC has many advantages over the methods of measuring temperature. It is more accurate and reliable than other methods as it requires a wide range of temperature. It is also faster and easier to use than other methods as it requires only single measurement. RTC is also less expensive than other methods as it requires only single device. RTC is also very versatile as it can be used to measure variety of materials. It is also very accurate as it can measure changes in resistance with very small change in temperature.
So guys, that's it for today. Thank you for watching.